In 2017, astronomers spotted something small and fast.
A survey telescope in Hawaii, Pan-STARRS S1, caught a faint moving dot of light that didn't match any known orbit around the sun.
When astronomers calculated its trajectory, they realized it wasn't looping around the sun at all. It was just passing through from deep space.
From the summit of a volcano on Maui, this tiny moving point of light quietly changed how we think about the space between the stars.
At its fastest near the sun, Oumuamua was racing at tens of kilometers per second, too fast to ever be captured by our star's gravity.
By the time we saw it in October, it had already passed its closest point to the sun and to Earth, and was on its way back out into the dark.
It dove inside the orbit of Mercury, swung around the sun, and then slingshotted outward on a one-way path into interstellar space. Once astronomers realized what it was, observatories worldwide scrambled to gather every photon they could before it faded from view.
We never got a detailed picture. All we had were faint measurements of its brightness as it tumbled through the night.
Those brightness changes were huge, suggesting that as it rotated, its cross-section changed dramatically.
Points.
Its color looked similar to many outer solar system bodies, likely darkened and reddened by cosmic rays over millions of years in interstellar space. But as it passed near the sun, there was almost no sign of a comet-like tail. No bright, deep observations from powerful telescopes found no obvious outgassing, limiting how much ice could be near its surface.
And then came the strangest part. Tracking showed a small extra acceleration that gravity alone could not explain.
As it moved away from the sun, Oumuamua sped up just a little more than expected, as if something were gently pushing on it. Comets can get that kind of boost from jets of gas, but Oumuamua showed no visible tail, no obvious jets, and no glowing coma.
Suddenly, the first interstellar object we had ever seen wasn't just unusual. It was behaving in ways that didn't fit any simple category.
That led to the big question. What was Oumuamua? A bizarre natural object.
Here's the solid part. It came from outside our solar system. It was strangely shaped. It had no obvious tail. And here's what we still don't know. Its exact 3D shape, what it's made of, where it formed, and whether its behavior is purely natural.
A 2023 study in Nature suggested that trapped hydrogen gas inside water ice could slowly leak out as the object. In this model, Oumuamua began as an icy fragment. Other scientists proposed it as a nitrogen ice shard chipped off a Pluto-like planet in another system, slowly eroding during a long interstellar journey.
Some models imagine a fragile, porous clump of dust and ice, lightweight enough that a little outgassing or
All these natural ideas must match the same data. The light curve, the color, the missing tail, and that measured acceleration away from the sun.
To get the observed push, Oumuamua would need a relatively low mass-to-area ratio, something thin or light compared to typical rocks.
That led some researchers to ask, what if it was a thin structure, like a sail, being pushed by sunlight itself?
A provocative idea emerged that Oumuamua could be a piece of alien technology, a damaged lightsail or probe drifting between the stars. Most astronomers still favor natural explanations. Alien tech is the most extreme possibility and requires the most assumptions.
NASA and ESA describe Oumuamua as a strange but likely natural object.
Official summaries focus on the facts, its interstellar origin, its odd shape, and the small non-gravitational acceleration likely caused by some form of outgassing.
Planetary systems often eject debris, small worlds, icy chunks, and rocky shards may have wandered alone for millions or billions of years before briefly brushing past our sun and disappearing again into the dark. 2 years later, another interstellar visitor, 2I/Borisov, looked much more like a classic comet.
Compared to Borisov's obvious activity, Oumuamua stood out even more.
No clear coma, no
On Universe Unlocked, we use mysteries like this to explore where real science ends and the unknown begins, without losing our grip on the data.
This channel exists to make the universe feel understandable, linking interstellar visitors, cosmic cutting-edge tech. While we debated what it was, Oumuamua simply kept going, getting dimmer with each passing day until no telescope on Earth could see it.
Today, it's far beyond the reach of our instruments, too small and far away for even our best telescopes to pick up. Researchers with the Initiative for Interstellar Studies proposed Project Lyra, a set of mission concepts to intercept.
By stacking gravity assists and powerful burns, some trajectories could, in theory, catch up to it in a few decades.
A close swing past Jupiter could fling a probe onto a high-speed intercept course, leveraging the giant planet's gravity as a slingshot.
Project Lyra studies suggest that missions launched in the 2030s or 2040s might.
At arrival, a small probe could photograph its true shape, map its surface, and directly sample dust or gas.
The difference between a noisy light curve and a high-resolution image is the difference between guessing and knowing.
An intercept mission could test whether it's solid rock, exotic ice, a porous aggregate, or even a hollow shell. In short, Project Lyra asks, can we turn a one-time mystery into a well-understood physical object by going there ourselves? Missions like this are stepping stones to our true interstellar exploration, where our spacecraft routinely cross the boundaries between stars. For now, though, most of the action happens right here, on screens, in simulations, and in conversations about
Natural models like hydrogen-rich ice or nitrogen shards have their own challenges, but they require fewer miracles than an alien lightsail drifting by at the perfect angle.
Media loved the alien ship angle, but the scientific story is slower and more careful, testing wild ideas, then keeping only the ones that survive the math.
Debate and disagreement are normal in science, especially when data is sparse. Oumuamua has pushed researchers to sharpen their models and their assumptions.
Simulations of planetary systems show that countless objects can be ejected into interspace, creating a background population of.
We expect there are many more of these passers-by. Oumuamua just happened to be the first one we recognized for what it truly was.
New observatories like Vera Rubin will scan the sky so deeply and often that future
That opens the door for pre-planned intercept missions, spacecraft ready to launch or redirect as soon as a new visitor from another star is detected.
At Universe Unlocked, we want a far future. Probe sends back.
Because every time we understand one of these visitors a little better, the universe feels less random and a bit more like a story we can actually read.
We only spotted it with our machines, but the fact that we can detect and trace such a fleeting traveler says a lot about how far our technology has come.
In the end, Oumuamua is both a physical object.
For students and researchers today, this little visitor is a doorway into a new field, studying objects born around.
Imagine being there with a probe, watching its real shape turn slowly against the stars, finally seeing what our data only sketches.
Instruments could read its spectra, measure its mass and density, and sniff any gas around it, turning wild ideas into hard numbers.
Would we find a jagged natural shard, or something disturbingly regular and engineered looking? Either way, following it into the dark would remind us just how enormous the stage really is, and how small we are on it.
Here's the honest summary. Oumuamua is definitely interstellar, definitely weird.
In science, you don't rule out possibilities just because they sound crazy, but you also don't accept them without evidence stronger than the alternatives.
So far, models like hydrogen outgassing explain Oumuamwa's odd behavior using known physics and lab results, without needing alien engineering.
Artificial intelligence will help us catch more of these objects, spotting faint patterns and strange orbits faster than humans alone ever could.
But even with better tools, some mysteries will stay unresolved for years.
That's why Universe Unlocked exists. To walk that line between what we know.
From interstellar rocks and alien megastructures to spacefaring AI and the fate of our own civilization.
Oumuamua itself is gone from our sight, but the questions it raised are here to stay.
So what do you think? Alien ship, exotic comet, or something we haven't thought of yet? Let us know your theory in the comments.
If you want to keep unlocking the secrets of space,